Okay, so this is question 5D from the mock paper. It says a solution of chlorine reacts with a solution of potassium iodide. A solid is made. Put state symbols into the boxes for the word equation for this reaction. So state symbols are not the symbols that are found in the periodic table. They're the symbols that tell you whether it's a solid, a liquid, a gas, or a solution. Solid is an S. Liquid is an L, G for gas, and then a solution would be AQ. AQ stands for aqueous, as in dissolved in water. Okay, so see here, it tells you in the question that it's a solution of chlorine, so you can put AQ into this box standing for solution. It also tells you that potassium iodide is also a solution, so you put AQ into this box as well. It tells you that one of the products is a solid. Okay, so you can recall from your knowledge of group 7, as you go down group 7, starting at the top, they are gases. So fluorine and chlorine are both gases. The next one down, bromine, is a liquid. And the next one down, which is iodine, is a solid. Okay, so you can put S in there standing for solid. The other compound, which is potassium chloride, you have to make an educated guess with. Because potassium iodide is a solution and potassium chloride is a salt, potassium salt with the same group 7 kind of element, so it's chlorine instead of iodine, but they're both in group 7, then you can make an educated guess that this would also be a solution. So you need to put AQ in here. So it says in the mark scheme, the first box is AQ, second is AQ, third is AQ, and the fourth one for iodine is S for solid. Okay, so part 2 asks you to write a balanced chemical equation for this reaction. So we need to use the periodic table from the back of the booklet. So using that periodic table, you should be able to come up with something that looks like this. We know that chlorine has got symbol Cl. Potassium iodide is made of potassium and iodides, so K and I. We know that potassium chloride is made of potassium and chlorine, so K and Cl, and iodine is the letter I from the symbol in the periodic table. The one thing that you do have to remember is that both the chlorine and the iodine are in group 7, and all group 7 elements are diatomic. That means they're made of 2 atoms, and so we've got a 2 here and a 2 here as well. So it's Cl2 plus Ki makes KCl plus I2. Okay, so that's part way there. But what you should notice is that it doesn't balance. We've got 2 chlorines here, but only 1 here. So to balance that out, we're going to need 2 lots of potassium chloride being made. Got the same situation happening here. I've got I2 and only 1 I over here. So if I put a big 2 in front of Ki, I've now got 2 potassiums and 2 iodines. So 2 iodines to match the 2 iodines here. And now we've got 2 potassiums to match our 2 potassiums here. So everything balances across the equation. We've got 2 chlorines here. 2 times the chlorine here is 2 chlorines. We've got 2 potassiums here, 2 potassiums here, 2 iodines here, 2 times the whole of this thing, and 2 iodines here. So that's now a fully balanced equation. If we look back at the mark scheme, you get 1 mark for getting the formulas correct, so having Cl2 plus Ki makes KCl and I2, and 1 mark for getting the number 2 here and the number 2 here, so the balance incorrect. Right, so part 3 says that chlorine atoms are very reactive. The chloride ions in potassium chloride are not very reactive. Use your understanding of electrons to explain why chloride ions are much less reactive than chlorine atoms. Okay, so we need to know what a chlorine a chloride ion is to be able to answer this question. So let's have a look. This is a chloride ion. You've got the chlorine atom, which is represented by the X's. Okay, so similar to how we drew the fluorine out earlier, but then we've gained that one electron there to make it an ion, just like the fluorine did. Okay, so we now know that this has got a full outer shell. It's got a full outer shell of electrons. That actually makes it more stable. It can't gain any more electrons, but it also won't want to lose this electron because that would make it less stable. So if we look at what the mark scheme is asking us for, we've actually covered it in our little explanation there. It tells us that the ion has a full outer shell. That's one mark, and so it can't take or lose any other electrons. That's the second mark. It's as simple as that. As long as you can explain what a chloride ion is, you can easily get that mark. Okay, so the last little bit of the question, section E. Okay, it asks you why potassium chloride solution conducts electricity, and you've got to put a tick in the box next to the best reason. Okay, so let's discount the ones that are either incorrect or talking about the wrong thing, and hopefully that will leave us with the correct answer. So the first one says potassium is a metal and metals conduct. Well, that's true, but we're not looking at potassium as a metal. We're looking at potassium chloride solution. Okay, so that isn't talking about the right thing, so that's incorrect. It says potassium chloride is made of ions. Again, that's a correct statement, but we're not looking at potassium chloride as a compound. We're actually looking at it as a solution. Okay, and this isn't talking about the solution. Okay, so potassium chloride solution, this is talking about potassium chloride, not specific enough. This next one says that a solution contains ions which can move. Well, we're looking at a solution, and potassium chlorides are both ions, and they can move. So this is all correct. We need to remember what electricity is. Electricity is the movement of charged particles. Well, you've got charged particles because you've got ions, they're charged particles, and in a solution they can move. So you've got the movement of charged particles. So this one is correct. The charged particles can move. It can conduct electricity. You might be tempted to put that water conducts electricity, and that's why potassium chloride conducts electricity. The solution conducts electricity. Well, water does conduct electricity, but we're not talking about pure water. We're talking about a solution. So we're talking about potassium chloride solution. Therefore, once again, this one isn't specifically talking about what is being mentioned in the question. So the correct answer is that the solution contains ions and they can move. This here is your correct answer.